A terrifying countdown in the deep cosmos has already reached zero. An apocalyptic explosion has occurred. Right now, a colossal blast wave of light is screaming through the freezing void, rushing toward Earth at 186,000 miles per second. When it strikes, our night sky will change forever. This is the imminent return of T Coronae Borealis, known to scientists as the Blaze Star. For 80 years, it has slept submissively in the shadows of the Northern Crown, completely invisible to the naked eye. But right now, thousands of advanced professional telescopes and millions of amateur skywatchers are tracking this exact point in the dark. The cosmic fuse is burning. A monster is waking up, and it is preparing to tear the darkness apart.
To truly understand the danger, we must look at the bizarre double life of this cosmic monster. T Coronae Borealis is not a lonely sun like our own. It is a deadly cosmic duo, locked together by immense gravity, trapped in a relentless dance of destruction. The system is composed of two completely different stellar objects. The first player is an aging, dying red giant. It has expanded to a monstrous size, and its outer layers are literally bleeding into the cold vacuum of space. The second player is a white dwarf, a tiny, ultra-dense stellar remnant, the highly compressed, faded core of an ancient star. It is roughly the size of Earth, but it packs the mass of our entire sun.
The laws of stellar vampirism. This is pure, unadulterated stellar vampirism. The white dwarf ruthlessly strips hydrogen away from its giant companion, pulling billions of tons of gas every single day. This stolen material does not simply disappear into space. It gathers in a swirling accretion disk, spiraling down directly onto the surface of the white dwarf. As the gas piles up, it gets packed tighter and tighter under the dwarf's hellish gravitational pressure. The temperature and density of this stolen layer rise to unimaginable levels, turning the surface into a celestial pressure cooker. The needle is slamming into the red zone, and the entire system is crossing the line from quiet accumulation to sudden, violent release. Nova versus supernova, the crucial difference. When the critical mass on the surface is finally reached, the result is a thermonuclear eruption of biblical proportions. Astronomers call this event a nova. It is vital not to confuse this with a supernova. A supernova represents the final catastrophic destruction and death of an entire star. A nova, however, is a superficial event. It is a colossal explosion occurring only on the outer skin of the white dwarf. The system survives the blast. The white dwarf sheds its blistering skin of fire, ejects the shell into space, and calmly settles down. Then, the terrifying cycle begins all over again, building toward another outburst, decades later. The great paradox of space and time. This brings us to the ultimate mind-bending paradox. Has the star already exploded? The answer is both yes and no. This volatile system is located roughly 3,000 light-years away from Earth. Mathematically, this means the physical explosion we are so eagerly waiting to see has already happened. It actually took place 3,000 years ago, during the ancient times of human history, around the era of the Trojan War. For 3 millennia, that apocalyptic flash of light has been traveling through the freezing void of space, rushing toward our modern world at the speed of light. For us on Earth, this cosmic event simply does not exist. Not until that thin beam of light
finally hits our atmosphere and strikes our instruments. We are not waiting for the actual explosion to happen in real time. We are waiting for its ancient echo to finally catch up with our current timeline. This is why the current suspense is not empty waiting. It is a live astronomical watch where every single second matters. Humanity has witnessed this specific star's fury twice before, with well-recorded eruptions in 1866 and 1946. Each time, it ran on a rough 80-year schedule, and now the next alignment is right upon us. For 3 millennia, that apocalyptic flash of light has been traveling through the freezing void of space, rushing toward our modern world at the speed of light. A new era of space observation. But back in 1946, scientists were practically blind. They had no space telescopes, no digital sensors, and no automated sky surveys. Today, if T. Coronii Borealis erupts, the global scientific community will meet it with the most advanced technological arsenal ever assembled. Space telescopes like James Webb and Hubble, orbital X-ray stations, and massive ground observatories will track the nova across different wavelengths. Every phase of the eruption will be captured in far more detail than ever before. But professionals aren't the only ones watching. A vast international network of amateur astronomers is tracking the system every night, ready to separate a real eruption from mistaken claims.
So, how can you witness this once-in-a-lifetime cosmic spectacle yourself? You don't need a $1 million telescope. You just need to know where to look before the sky changes. First, you need to locate the constellation Corona Borealis, the Northern Crown. It is a small, beautiful, semicircular arc of stars nestled right between the larger constellations of Bootes and Hercules. A great trick for skywatchers is to look in the region between 2 ultra-bright guide stars, Arcturus and Vega. Learn this part of the night sky now, because when the blast wave of light arrives, the transformation will be sudden.
When the nova finally hits its peak, do not expect Hollywood-style special effects. You won't see a giant fireball moving across the horizon or an expanding smoke cloud. To the naked eye, the scene will look serene, yet profound. Where there was absolutely nothing but pitch-black empty space, a brilliant new star will suddenly materialize. The star will jump dramatically from magnitude 10, completely invisible, to about magnitude 2. This will make it as bright as the North Star, visible even from light-polluted cities. But you must act quickly. The peak brightness will last only a few short days before the thermonuclear fires cool and the star fades away for another 80 years.
The show of the century. As of this moment, the night sky remains quiet. The cosmic fuse is lit, the countdown is running, but the final signal hasn't reached Earth yet. T. Coronii Borealis is keeping us in suspense, holding its breathtaking secret for just a little longer. But the universe always delivers on its promises. And the window to see it will be incredibly short. When that light finally hits our planet, it will remind us of a profound truth. We are living in a golden age of space observation. For a few intense nights, humanity will look up together, watching a nuclear forge burning thousands of light years away. It is a humbling reminder of how dynamic and alive our cosmos truly is. That's all for today's deep dive into the secrets of the cosmos. With you was Nina Sobelfeld. Make sure to hit that subscribe button, turn on notifications so you don't miss the big blast, and as always, to be continued.